it's your boy Marcus back for another session on coding SpriteKit. So in this series we are learning how to make a game in SpriteKit. The way we're doing that is we are going to make a game which is a clone of the 80s arcade game Asteroids. So if you don't know what Asteroids is, it's a game where you fly a spaceship around the screen and you destroy asteroids for points. So in the last few videos, actually the last 5 or 6 videos, we've been attempting to refactor this app just because we have a lot of spaghetti code and a lot of dependencies between the functions and so forth. So we really want to refactor it so it's more manageable and more understandable and overall safer because it's going to be more encapsulated. So the changes, for example, are going to be contained within one unit of code or one body of code versus having one change affect the whole code base. That's what encapsulation is. So the last time we were here, we were discussing creating a rotate button node. So this is our rotate button node, and this is a node that rotates the spaceship on the screen either left or right depending on which button you press. So I really wish I can show you what the button looks like, but right now I have some code in there that's giving me some errors. Just because I put in, some template code in there that doesn't really do anything. It's just kind of like a note for me on what to build out. So the app won't run right now. I won't be able to show you what it looks like right now. But where we're at is we were trying to implement the rotate button node. The reason why we're doing that is to separate the button into a different class versus just declaring the button on the main screen or the main scene and having to modify that button on the main scene, because that's just a lot of work for the scene to do. But since the last video, I do want to mention that I talked to my mentor who's been helping me with this game, and he basically showed me how to divide up the code into different classes and use inheritance so that we could have a more sensible architecture. So what he suggested is to have separate levels of classes. So let me show you what we'd have. For example, okay, so let's take, actually I think we could take the rotate button node. So basically what it breaks down to is at the very highest level, the very highest superclass will have something called a button, or we might call it like a UI element, whatever we want to name it, but it's going to be very generic and we'll have certain functionality in it and certain customization. So as I'm talking right now, I can just think that at the very highest class or at the very highest level, we're probably going to have one superclass for all the different stationary buttons. And the stationary buttons we have are the left rotate, the right rotate, we have the trigger, and we also have the thrust. So those are the 4 stationary buttons. They're going to have similar implementations. They're going to have the same color. They're going to have fixed positions, although they each have different positions. Each one of them is going to have their own fixed positions. So they all have fixed positions. They're going to have the same size. They're going to fetch assets the same way. So that's one superclass that we can probably implement in this video. So we're kind of starting from scratch. It's going to be hard to implement and have our functionality going. But for this video, I think what we'll do is just try to implement that superclass And what we want it to do is be able to, I don't know, almost set it like a protocol. So we might have the superclass as a protocol instead of just a superclass that we inherit from. And the protocol pattern allows us to make a requirement for anything else that follows the protocol, meaning things that follow the protocol would have to implement some certain methods or contain some variables. So that's sounds like something we want to do. So we'd have this superclass, which is a protocol. The different things that we want it to actually implement is we want it to implement size, color. We want a generic method to fetch assets from our asset library, and then we want it to have like some sort of gesture recognizer. So each one of these buttons, it's going to be able to detect whether or not it's been pressed. So that's some functionality that each one of the child classes should have. So if we create a protocol like this and make it a requirement to implement all those, we're going to have almost like a template on how to implement buttons. And that's a good thing, because if a lot of buttons are uniform, then having a template and a repeatable way to implement those buttons is going to be great. It's going to make it way easier to understand and implement. So we'll have the button class. I think I'm going to do it here. So I'll call it stationary button. Stationary button. And we will call this stationary button. Stationary button. And before we do anything, let's go ahead and ask ChatGPT for a refresher on how to implement a protocol. So we'll just say, how do I implement the protocol pattern? Call pattern in Swift. And this is just going to be a refresher for those of us who kind of forgot how to implement the protocol pattern. It's been a long time since I coded in earnest. Last time I coded in earnest was a few years ago when I was building a previous music teaching tool. That's the one I got the furthest with. Some other apps I've made didn't really get that far, kind of just ditched them halfway through. But now we're coding in earnest. We are asking some real questions on what we need to do. So ChatGPT says the protocol pattern in Swift is used to define a blueprint of methods, properties, and other requirements that suit a particular task or piece of functionality. A protocol then can be adopted by a class, struct, or enum to provide actual implementations of those requirements. Here's how you can implement the protocol pattern in Swift. A step-by-step guide. Alright, so we have 3 steps. Step 1 is define a protocol. Declare a protocol with the required methods and properties. Okay. Adopt a protocol. A class, struct, or enum can adopt the protocol by providing implementation for the required methods and properties. 3. Use the protocol. You can use the protocol as a type for variables, parameters, or return types. Okay. So it's saying that it's a type, and a type is just either a struct, class, or enum that has some functionality, or variables that we can implement as kind of a packaged way to deliver functionality. A type does whatever you want it to, and you can instantiate a type, and it turns into an object through which you can access the functions and variables of that type. And they can do all sorts of different things. So that's what a type is. Might seem basic for me to explain that, but we are learning, and I hope that shed some light for those of you who didn't know what it meant by a type. So it's a type just like a class, structure, enum. That's what a protocol is. Here's an example implementing a protocol for game entities. Let's say we want to create a protocol for game entities in a SpriteKit game. This protocol will define the necessary methods and properties that all game entities must implement. Step 1, define a protocol. So here's our example. Import SpriteKit, protocol game entity, variable sprite, SK_sprite node, and it has a get method. I don't know why it has a get method, but it is getting. Func update, func did collide. Alright, so in this example, we just have the signatures of the functions that we need to implement for whatever actual instance of this protocol we have. So we have this protocol as a type game entity. It has these signatures, it has these variables that we must implement when we instantiate a object of this protocol type. Alright, so we have step 2 now, adopt the protocol. Now let's create a spaceship class and an asteroid class that adopt the game entity protocol. Alright, so this is a class that inherits from game entity. So here we have this inheritance type syntax right here. We have the spaceship, colon, and then we have the game entity. So it looks just like as if we were inheriting. So this is the way we write the syntax to denote that we are inheriting from game entity, this protocol up here. So spaceship is adopting this game entity protocol, and then we have implementations of the necessary functions. So game entity up here says we must implement this variable called sprite, and we have declared it right here. So we've fulfilled that requirement to implement sprite, right? And then in init, we're giving sprite some other properties like physics bodies and category bitmask, contact bitmask. Those are all just used for collisions. And we're setting up the texture, which is, you know, an intermediate step that you need to take in order to, you know, have the sprites be able to become or have physics in it, if that makes sense. So the sprite, we have a physics body, and we input a texture and size, and this physics body is part of this sprite now. So anyway, I am going off on a tangent, but basically what is happening here is we're declaring the sprite, which is a required variable from the protocol, and then we're modifying that required variable in the init method. And then if we go further down the code, we have this func update function. So this func update function / method is a required function. So if we look up here in game entity, we have the update function here and its signature. You'll notice that this function signature matches this function signature exactly, right? So that means this class spaceship has successfully implemented yet another required function from game entity, and that function is update. So we're implementing update with the same signature. Then we have the custom functionality within the body of the function. By the way, I'm just going to try to call them all methods, just because they are part of a class. But what I mean is just a function, because that's what they are, but they're also technically methods because they're part of a class. Anyway, so this method has been implemented. There's just a comment here in the body of the update method, just saying that we could include custom functionality in this method. And then we have func did collide. So this method is also the last required method that we declared in the protocol. So this class has fulfilled all the required functions or required functionality inside of it, right? So this can successfully adopt the game entity protocol, which requires these three pieces of information, right? So we can have some custom functionality here and here. So that's all well, fine and dandy. And then we have another thing called Asteroid. So this class is called Asteroid, and it also inherits / adopts the game entity protocol. So we'll look for the same things, the required pieces of information. We have the sprite, that's good. We have update, that's good. Did collide, that's good. So just like this class up here, spaceship, this class down here, Asteroid, is adopting game entity protocol, and it is successfully doing so because it's implementing sprite, update, and did collide, which are the required methods and variables that we declared in game entity. So the last step is use the protocol. So ChatGPT says you can now use the game entity protocol as a type. This allows you to write more generic code that can work with any game entity. Alright, so what we have here is class game scene. Class game scene actually comes with every SpriteKit game. So when you first just get all the stock standard code, the boilerplate code, when you create a SpriteKit game in Xcode, it just gives you this boilerplate code. Game scene comes with that boilerplate code and just represents what the screen is. It's like the background of the game, and we put things onto the game scene so that the users see things that they can manipulate, and in our case we can move a spaceship across the game scene, so things like that. So the game scene is where we put things onto the screen. So we have variable entity. This is a array of game entities. So this is interesting already. So we have entities. It's going to be array of game entities. So that means the data type is game entity. And just like ChatGPT mentioned earlier, the data type game entity is actually a protocol. And this game scene here is saying that we're going to have an array of game entities. So we're going to have an array of objects that meet the protocol that we declared. So let's go further. We have override func did move to view sk view. Alright. So did view, this method is actually what's run at the very beginning on game scene. It's the first entry into the code that is what's executed first. So it's kind of like an init method for the game scene. So you can see inside did move we have a physics world, contact delegate. So this right here is interesting. So physics world, I don't know what physics world is. So before we go too much farther, let's ask what physics world is, because I think it's a stock standard. It's a stock standard keyword / object that comes, or a property that comes with game scene. But we could be wrong, we could be right. So let's just straight up ask ChatGPT. So we'll say, what is physics world? So let's get ChatGPT to educate our big fat butts. So ChatGPT is being very verbose, like it always is. Thank the Lord for explaining everything. ChatGPT. Here we go. So it's giving us a mile-long answer, which is good. I love it. Alright, so let's read through part of this so we can get an explanation. So ChatGPT says physics world is a property of the SK scene class in SpriteKit that represents the physics simulation for the entire scene. So it's part of the SK scene class. So I mentioned before that game scene is stock standard boilerplate that comes with SpriteKit. But this game scene actually is a subclass of this SK scene type. So the SK scene type holds all the functionality that we need to operate the screen and put things onto the screen. So SK Scene is the superclass that holds all the functionality that we need in order to present something to the user. So back to the explanation of Physics World. So Physics World is a property of SK Scene class in SpriteKit that represents the physics simulation for the entire scene. It allows you to configure various physics-related parameters and interact with the physics engine to handle collisions, apply forces, and simulate real-world physics within your game scene. Here's a brief overview of what you can do with Physics World. So let's read at least this part. So you can set the gravity. You can configure the gravity for the entire scene, which will affect all physics bodies within the scene. You can set the contact delegate. You can assign a contact delegate to handle collision events between physics bodies. 3. Perform ray casting and other physics queries. So I don't really know what that is, but apparently you can use methods provided by Physics World to perform various physics queries like ray casting, which can help detect objects in a line of sight or other complex interactions. Okay, that's cool. Simulate physics. It runs the physics simulation that updates the positions, velocities, and interactions of physics bodies over time. Okay, so we kind of got we did a cursory glance at Physics World. I think we get the basics. So Physics World just basically lets you declare like the global properties of all the physics bodies inside SK Scene. So yeah, that represents the physics simulation for the entire screen. So that's what it is. So how much time do we have left? Okay. So that's what Physics World is. So let's go back to the protocol question. So we have this Physics World contact delegate. So the delegate is going to be the self. Contact delegate is the self. So that means the self is a delegate. This class game scene is a delegate. So if I remember correctly, the delegate carries out the functionality of the protocol. So let's actually make sure that that's what it is. So let's just go ahead and ask ChatGPT what SK Physics contact delegate is. So let's let us ask that question. ChatGPT is again being very verbose. That's what we like. That's what we want from our AI. ChatGPT! The little AI that could. Keep going, ChatGPT. You could do it. Alright. So ChatGPT says, oh, it's still going. Let's wait till it finishes. Man, I'm tired. I am so freaking tired. Oh my god. Alright, let's keep going. Alright. So ChatGPT says SK Physics contact delegate is a protocol in SpriteKit that you can adopt to handle collision and contact events between physics bodies in your scene. When two physics bodies with overlapping contact test bit mask values, so let me read that again. When two physics bodies with overlapping contact test bit mask values come into contact, the delegate methods of SK Physics Contact Delegate are called, allowing you to define custom behavior for these interactions. Alright, so I get that. My question is, how does that relate to our game entity protocol? Let's check back to see the game entity protocol. Alright, so we have protocol game entity. Nowhere do we mention SK Physics Contact Delegate. So that's a little confusing why I didn't mention that. Maybe we didn't declare SK Physics Contact Delegate because it's already a stock protocol that comes with Swift. That's what I'm guessing. So in the contact delegate we have did begin and did end. Okay, kind of self-explanatory what those do, but I'll just read it anyway. So did begin is called when two physics bodies first contact each other, and did end is called when two physics bodies stop contacting each other. So where do we ever relate the physics contact delegate to the protocol? Let's see. Let's go back here. Game entity. We have an array of game entities. That's fine. Physics world contact delegate. So this class game scene is going to be able to manage collisions. So we have spaceship. Instantiating a spaceship. That's fine. A spaceship. Sprite.position. CG point. So we are setting the position of the SpriteKit through the sprite property. So remember, we have a class named Spaceship up here. This class is Spaceship. It's inheriting from the game entity / adopting game entity protocol, and it has a variable called Sprite, which inherits from SK Sprite node. So when we're down here in the game scene, we are where are we? When we're in the game scene, we are declaring a spaceship, which is our own custom type, which adheres to the game entity protocol, right? So this spaceship, this constant right here, is an object that adheres to the game entity protocol, and because it adheres to the protocol, we have this variable called Sprite. Sprite itself inherits from SK Sprite node, which has a position property, and the position property takes a CG point. So that is the chain of execution, I guess, or the chain of inheritance / property ownership. And then here we are just adding the child, which means we're adding the node to the screen, and then we are appending spaceship. So this is a node, spaceship, and it is a game entity because it inherits / adopts game entity protocol. So that means we could append it to this array of game entities. So this game entity is just going to be a collection of the different nodes that we have on the screen. In this instance, it's going to be game entities, and in this case, we are appending asteroid, or we're appending spaceship to that collection. And then pretty much the same thing for asteroids. And then we have this func update method, which is a required. That is a required method inside the protocol. So we're implementing this protocol. Yeah. We're implementing this protocol update. See, my question is, why aren't we adhering to the game entity protocol? I honestly think ChatGPT made a mistake. I think this is supposed to be SK scene, comma, SK physics contact delegate, comma, game entity delegate. So let's ask ChatGPT if it made a mistake. Why is the class declaration like the above? Don't we somehow need to adhere? Don't we somehow need to make it explicitly adhere to the protocol called game entity, or at least mention it somewhere? Let's ask ChatGPT that question. Hopefully it'll shed some light on why. Alright. So it looks like it's giving us an answer. So yeah. So let's make it in its example right here, the game scene is inheriting from game entity. So let's make it, and this, example has the required variables as health, and then this function or this method take damage. So we'll say give me sample code using your first declaration of the game scene class, your first sample declaration of the game scene class that is supposed to inherit from your first sample of the game scene of the game entity protocol that implements Sprite update, and what else did it implement? Sprite, let's see. Sprite update and did collide. Sprite update and did collide. Please tell me if this is necessary. If it is not, if it is, tell me why. If it isn't, tell me why. We are learning. We are learning so hard right now. Dude, we're learning. We're learning like freaking sponges, dude. We are SpongeBob SquarePants in a coding class. I can't do a SpongeBob laugh. So let's see what ChatGPT. So ChatGPT says, in your game development, it's crucial to determine whether separating responsibilities into protocols and classes is necessary. Here, I'll provide an example using your game scene class and a game entity protocol to demonstrate handling sprite creation, updating, and collision. I'll also explain why or why not this separation might be necessary. So that's not what I want. What I want to ask is, if we've declared classes that do adhere to the protocol, if the instantiated objects of the protocol type, if the class that instantiates objects of the protocol type needs to implement the protocol as well. So that was not what I meant to ask. I'm asking when we have a protocol, does the class that instantiates objects, does the class in which we instantiate objects of the protocol type, so that was not what I meant to ask. I'm asking, when we have a protocol, does the class in which we instantiate objects of the protocol type need to somehow adhere to the protocol or reference the protocol in any way? That's a kind of very fine-grained question. This is our shit. This is our time. It's our time down here. It's our time. Our time down here. Goonies never say die. Goonies never say die. It's our time. Our time down here. It's our time. It's our time down here. Alright. So ChatGPT is lagging. It looks like it's frozen. My God, Mother in Heaven. Holy Mary, Mother of God. Come on, ChatGPT. You can do it. You're the little AI that could. I believe in you. I believe in you, ChatGPT. You are the smartest piece of technology in the goddamn fucking universe. If anybody's wondering what this thing is, this fucking arm thing, it's It's a mount that holds my cell phone, so I could use my cell phone as a webcam. So I could do OnlyFans. But mostly, mostly when I'm not doing OnlyFans, I use it for use my cell phone camera to just run a live feed of my Magic cards when I'm playing Magic. There's this website called Spell Table where you play Magic the Gathering with real cards live on a webcam. So my phone is in a mount being used as a webcam to play Magic the Gathering. Oh wow. So that's what this arm fucking thing is. I'll try not to get in the way. So, that was my question. Let me rephrase my question. So, my question was, so that was not what I meant to ask. I'm asking, when we have a protocol, does the class in which we instantiate objects of the protocol type need to somehow adhere to the protocol or reference the protocol in any way? So ChatGPT says, no, the class that instantiates objects conforming to a protocol does not need to adhere to or reference the protocol explicitly. Okay. The class only needs to know that the objects it's dealing with conform to the protocol so it can call the methods and access properties defined by the protocol. Okay. Protocol. Game entity. Sprite, health, update, did collide. So we have spaceship adhering to the game entity protocol. It implements all the required methods and variables, and then we have a class using objects that conform to the protocol. So this is where we got tripped up recently. So we have the game scene that inherits from SK scene and adopts the SK physics contact delegate protocol. We have the spaceship being declared. We have updates. And then we have did begin. So my question is, why are we including this update method? Where is this update method coming from? Override func update. So what are we overriding? So super update current time entity did begin. Okay. So we got our answer. The game scene, even though it instantiates the objects that inherit and adhere to the protocol, itself doesn't need to reference the protocol. Okay. So let's look at this explanation. So, 1. Protocol definition. The game entity protocol defines a set of requirements that conforming types must implement. Okay, so we know that. 2. Class conforming to the protocol. The spaceship class conforms to game entity by implementing the required properties and methods. Okay, we know that. And then we say class using protocol conforming objects. The game scene class instantiates objects of type spaceship and interacts with them through the game entity protocol. Alright. See, that's where I'm confused. It interacts with them through the game entity protocol. So I'm guessing that just means accesses properties that are declared in the protocol, and we know that they are part of Spaceship because Spaceship conforms to protocol. That's a weird way that ChatGPT says it. So, important points. The game scene class does not need to conform to the game entity protocol itself. It only needs to know that objects in its entities array conform to game entity. The game scene class can call the methods and access properties defined in the game scene protocol on any object in the entities array. This separation allows game scene to work with any object that conforms to game entity without needing to know the specific details of each type. This is one of the main benefits of using protocols. They provide a way to define shared behavior across multiple types while keeping the implementation details encapsulated. So that all sounds great. Hey guys, I'm going to need to cut it short because I really have to go to the bathroom. I'm going to splice these videos together so it's all going to look like one video. So you're going to see me in half a second, but just know that 50 years have been passed because I ate a lot of hot sauce and drank a lot of caffeine. So I'll be right back. Alright, guys, I am back. So it's been 50 years. I shat out my brains, basically, what happened. So now that I don't have any brains, maybe I'll do better because my brain keeps tricking me. Anyway, so we were talking about instantiating objects that conform to a protocol, and we found out that classes that instantiate objects where the objects conform to a protocol don't need to conform to the protocol themselves. So the individual objects, if they conform to the protocol, we know that we have some required methods and variables implemented. So relating that back to our game, we could definitely create a protocol that implements some required methods and variables. So far right here in the stationary button class, I have a couple comments, 3 comments actually. The position, color, and size. So we are going to make sure that we implement each of these things in individual objects that we instantiate. So why is this not? What do we have a capital here? Alright, so this is our protocol. So we're going to have a color, size, we're going to have a position, color, size. So let's just declare those right now. We'll say color, and we'll make this, what are we going to make this? Computed property. What data type is this going to be? Let's check out the entity, game entity. So it looks like in the game entity up here, they have a sprite, which is a required variable that inherits from SK Sprite node. So that's fine, but they have this get and set keyword. So I don't know what that's about, honestly, because they don't have get and set down here. So let's ask ChatGPT. So I know we're asking about all these niggling details, but I think it's necessary for us to learn. So we want to ask what it does. What? So why do we have to include get and set if we don't use it in the instantiation? Okay. So our question was, why do we have to include get and set if we don't use it in the instantiation? So ChatGPT says, in Swift, you define a property with protocol with both get and set. You're specifying that any conforming type must provide both getter and setter implementations for that property. This means that the property can be read and modified. The get and set specifiers in the protocol definition are about enforcing the contract that conforming types will meet these requirements, rather than about how the property is instantiated. Here's a more detailed explanation. Protocol definition with get and set. Okay. So we have two variables that have get and set. Conforming class. Class, game entities, sprite, health. Alright. Why get and set? Flexibility and extensibility. By specifying both get and set, you ensuring that conforming types both read and write access to both provide read and write access to the property. This makes the protocol more flexible, allowing the property to be modified as needed. Encapsulation. The get and set specifiers encapsulate the property's read and write capabilities, ensuring that conforming types adhere to the expected interface. This helps in maintaining a consistent API across different types. Conformance enforcement. When a type conforms to the protocol, the compiler enforces that the type provides both getter and setter implementations of the property. This ensures that the type meets the protocol's requirement. Example, updating the property. Here's an example showing why having get and set might be useful. So we have func update entity, which accepts a game entity.sprite.position, CG point. Okay, we're setting the position. Entity.health -10. So we're updating it with -10. And we're calling update entity here. So what does it say? In the update entity function, we need to modify the sprite property and the health property of the game entity because the protocol specifies get and set or guarantee that these properties are both readable and writable. When only get is needed. In your case, if your case only requires reading the property and not modifying it, you can define the protocol with get only. Okay, so I think we're going to set have get and set. So what's the data type of this color? So we can go to, I guess, the game scene and figure out what data type this color is going to be. So let's Command F, color, search on it. Tint color. So we may be able to just copy this. What is this pulsing sound? Do you hear that? No idea what that is. Okay, so let's go back to the button node. Thrust button. Where's the button? Stationary button. Variable color. What is the color? So I don't know if we're implementing color that way. It might be a UI image. So stationary button. So we are not searching a stationary button right now. As of now, that's not what we did with Command F. We want a stationary button. So what are we finding with Command F? We gotta find a button. Alright, generate buttons. So what do we have here? Left arrow. So in a button, let's say the button's called left arrow. What do we need to implement inside of what do we need to declare inside of the left arrow? So it looks like we need to instantiate a UI image class. So the left arrow, this is so weird. So the left arrow is a UI image here. So if the UI image, if the left arrow accepts a UI image, so I guess this is an asset. So if we're going to have a button that inherits from SpriteKit node, and the Sprite node okay, this is the left arrow node. Yeah, so the left arrow is a UI image, then we're modifying the UI image. Eventually we get to here, which is the left arrow node. So that's actually our button. And that's a SpriteKit node. Right? So in the SpriteKit node, what do we need? We need this. We need, I guess we need an anchor point. Size, position, Z position. So we need a texture. So basically we have data, new image, texture. Those are all going inside of left arrow node. So can the left arrow node, can we just make sure that the texture goes into the left arrow node? So my question is, can we do, so as far as this property right here, can we say self dot texture is texture? Can we do that? Because here I want to say texture sk texture, and then we'll say get set like that, and then maybe we have a knit, and then this accepts all of keep going back. So this accepts all of this stuff. So this stuff will be sent to the node as an init. So we'll have a class for a button, I guess. So maybe we have a separate image class. So if you get what I mean. So imagine this left arrow was called left arrow image, and then we just had an instantiation of a separate image class, generate image or something. So we could, I guess, do that. So what I'm thinking is we go new file, we go Swift file, image, so we have here import SpriteKit, and then this is called class image UI image. And what does this need? Okay, I keep clicking back to ChatGPT. So it inherits from a UI image, right? So UI image needs what? System name, tint color, system name, tint color. So can we implement those? Can we do this? So can we do this? So var system name and this is a string. Oops, not in quotes. So this is a string, and then this is get set, and then we have another variable which is tint color, I guess. Keep clicking back to ChatGPT. Tint color, image, a stationary button. So image. So we'll say why is this an error? Oh. So expected pattern. Okay, so we're gonna say tint color. This will be what? I keep going back to freaking ChatGPT. Keep clicking this like side window, stage manager window, but I like stage manager, so I won't change it. So let's go back to game scene, and this accepts what? What is this tint color thing? How do we find the data type of this? What is the data type of tint color? So we'll say how to, we'll ask ChatGPT. So we'll say how to find the data type of a property. Da 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 da. Hey, da 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 da. Hey. For way too long. For way too long. For way too long. Come on, ChatGPT. Oh, page is unresponsive. Oh my god. I'm looking forward to tomorrow. I think, so this is my second hour of doing this today. I'm going to try to do it 2 more hours so I can get 4 hours in. No, I'm saying try to do 2 more hours. It's honestly pretty fun. So in Swift, there are various ways to find out data type of property. Here are some of the most common methods. Use the option click in Xcode. So option click. Option click. How do I do option click? With tint color. Tint color is a UI image. Tint color is a UI image. What? Oh, tint color returns a UI image. So this is a function, I guess. So it's a function that accepts a UI color. So so we need this. Yeah, I should have been able to guess that. So we need this. So it has to be self, or we don't have to do that. But eventually what we want to do is self dot with tint color keeps wanting me to set tint color dot self, and then we have dot white. You know what, why are we, we know they're all going to be white. But let's just make it extensible by being able to upload any color and have it up to the instantiated object to determine the color. That way, ever in the future, if we want to change the color, we can. Dude, I am so freaking sleepy right now. It's unbelievable. But I know that if I were doing something a little bit more entertaining, I'd wake up. So literally, I know my body can handle it. Okay, let's keep going. So dudes, I'm so freaking tired. It's unbelievable right now. Oh my god, I'm so freaking tired. Okay, I'm gonna cut it short again and splice this video again. So there's gonna be another video after this one that's spliced to it. It's gonna seem like half a second to you, but for me it's gonna be like 10 minutes because I'm gonna go get caffeinated and be right back. So see you guys. Is up, my dudes? So it's been half a second for you guys, but I actually peaced out for about half an hour while I was getting caffeinated. I had 2 scoops of pre-workout, which is like 270 milligrams of caffeine, almost as much as a Bang energy drink. So it's quite a bit of caffeine. I'm still kind of tired, but definitely more perky than half an hour ago. So let's just go ahead and do our shit. So we're implementing a protocol for stationary button. We're setting the required variables and methods in here. So far we have the texture, the SK texture. What a texture is basically something that an SK sprite node can accept, and that's usually like an image or some modified asset. I don't know much further than that, but SK sprite node accepts a texture, so that's why we're setting it as a required variable here, because when we instantiate this stationary button, we want to set the texture of this button. So SK sprite node already has a texture. So most likely in this texture we'll say self.texture equals texture. So we'll say self to access the member of the SK sprite node, like the superclass, and then we'll set that to this texture. And then the other thing we have is the tint color. This tint color is a method that accepts a UI color, right? So when this method is called, it's going to accept a UI color, and we're gonna, when we pass a UI color to it, it's gonna return a UI image. So the UI image, let me get back here. So the UI image is going to be appended to after this image. So actually we need a UI image. So this, oh wait, my bad. Let's get rid of this. This is my Magic the Gathering deck. Let's get rid of that. Let's get rid of that. So stationary button. So it's going to accept this UI image, right? And then we should also make the stationary button accept a UI image as well. So we'll say variable image equals UI image. And the reason why we set that UI image is because hold on one second. The reason why we have this UI image is because we need to put a UI image in a texture, and the texture goes in the SK sprite node. So we'll pass a UI image here, and then we'll put it in here, and then we'll say self.texture equals this texture. So I'm just doing that because this is how we have it implemented here. So this left arrow is actually a UI image with these modifiers, the tint color. And then we modify the image. We take the image data or whatever, which is just modifying the PNG, and then we put it inside this texture. So actually what we have is wrong. So this should not be this UI image should not be in SK Sprite now in the stationary button. It should be in the image class. So we'll call this asset, image asset. Let's call this an image asset. Set the get. So we'll just say asset. And it's complaining because we have no initializers. So it's kind of jumping the gun a little bit. We're going to set these with an init method. So tint color, where's that? We should not have the tint color in here, I don't think. So I think we should have the tint color in the UI, in the image. So the class UI image class UI image. So what is this going to be? So we're going to have init, and this is going to accept a UI image. I think it's going to accept a UI color. So UI image accepts a UI color. So we're going to say color equals UI color. And what else is going to accept? It's going to accept system name. Let's make this available. So let's make it an argument label. So it's going to also accept system name, which is going to be a string. And then let's go in order. So it's going to be an asset, UI image, and then we're going to say system name. Name is going to be a string, a strong. And we'll put this right here. UI color. So we're overriding UI image. Must be provided by subclass of UI image. So we're making a custom UI image. With tint color. Coder. What is this? Okay. Image literal. Okay, so I don't want to deal with overriding UI image. There seems to be a lot of requirements for overriding. So we're just not gonna override UI image. So let's get rid of all this. So maybe we can put all the image modification code in the stationary button. Yeah, so I think we could do that. So we have an SK texture. Let's go back to game scene to see what we need to implement. So it needs a UI image. So we'll call this, I guess, asset. So we'll call this asset, var asset, and this is going to be UI image. Is it an image asset though? What is the data type of this? It's just a UI image. It's not an asset, I guess. The thing about using this, the arrows and such, is okay, so the problem is if we make the required variable for the asset, so in our button, in our stationary button here, we definitely want to accept some sort of image, whether or not that is a system image like from SF Symbols. SF Symbols is like a built-in library for Mac. So whether or not we have an SF symbol, which is a system image, or we have an image asset, we want to accept an image, and it can be either or. So what I want to do is write like one conditional statement that can accept both a UI image and also something else. So let's check the other buttons. So we're in game scene. Generate buttons. The left arrow is a system image. This is a system image, as you can tell by the system name. And this is also a UI image, but this is not a system image. This is just an asset. So I guess they're both UI images, but they accept something different. So I guess we can just, let me see if I can just declare the data type. So if I say asset, if it's a UI image, can I just set a getter and a setter and then have it just be accepted like that? Yeah, no errors. So we're getting no errors right now, which is a good thing. So we have an image. What else do we need? We need data. We don't need data for all of them. Can we make a protocol of a protocol? So let's say we have a protocol for just a general asset. Can we have a sub protocol that requires different things? So we'll say, can protocols be required to conform to other protocols? Okay. So this is cool. We have a protocol called drivable. Then we have a protocol called maintenance. Then we have a protocol called car. The inherits from drivable and maintenance. And each of these three protocols have their own requirements. So what I want to do is I want to make a protocol for assets that come from our asset library, and then assets that come from SF symbol. So stationary button. Stationary button. So what am I going to do? So stationary button, I'll make a new file, and then so I will make this a Swift file. I'll make it asset library protocol. Yep. I'm going to change the name of this. So I'll change this to stationary button protocol. Protocol's a funny word. Protocol. If you say it like protocol, then each O has a different sound, kind of like Mercedes. Mercedes. All three E's in Mercedes have a different sound. It's crazy. Mercedes. 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 All three E's have a different sound. Crazy. Crazy for feeling so lonely. Crazy. Alright. So we have a texture. What else do we need? God, I keep clicking away to the ChatGPT chat. Alright, so only in so we have system name. We have a tint color in each of these. So I think the tint color can go in all of them. So we'll put that in the stationary button protocol. So we'll say func with tint color, and that'll return a UI image. Of course, we need the parentheses. Parentheses. Mercedes. Okay. What else we got? What else we got? What else we got? What else we got? Stamps.com. Stamps.com. Alright. Come on. Come on, you can back, get back into it. Tell us why, show us how. Look at where you came from, look at you now. Okay, what else do we need? So, we need the data. We don't need the data. So this data, new image, texture is, it's not here. But we do need texture. We need texture and we need the node. Texture and node. Look at where you came from. Look at you now. Texture and node. So we're going to go stationary button protocol. We have asset, texture, var node, sk. Well, the node is the node is this. This is the node. This is going to be dot texture equals texture. We're going to go self dot texture equals texture. That's what we're going to do. Look at where you came from, look at you now. So we don't actually need a node, but we do need some other things. Look at where you came from. We need anchor point, size, position, Z position. So let's just copy this. Do all of them have this? Anchor point, size, position, anchor point, size, position, Z position. Perfect. 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 Grab kills and put a little makeup. This is going to be a CG point, pozoint, anchor pozoint, anchor pozoint. This is this is going to be var anchor points size. Var size equals CG size. It's going to be CG size. By the way, all these going to be like self. And all these are going to be in the init method. So yeah. I'll show you what I mean. In the init method, it's going to be all selfs. Z position int. Int. Holy Mother Mary of Mary. Get set, get set, get set, get set. Look at where you came from, look at you now. Set, get set, go. Get set, get set, get set, get set, get set. Perfect. Perfect. I vape, guys, by the way. I'm not going to vape on this video, though. Look at where you came from. Look at you now. And by the way, that's why all my videos are 18 years old plus. should be 21 plus because 18-year-olds in California can't buy vapes. It's only 21-year-olds. Look at where you came from. Look at you now. Yeah, so the init method is going to have all this special stuff. It's going to be init all this stuff. This thing, this thing, this thing. Look at where you came from. Look at you now. It is very much the same, yes. Once it goes through the compiler, there is no difference. Tabs have smaller file sizes. I work at a compressions company. I know about minimizing file sizes. Hey Richard, tick 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 tick. Look at where you came from. Look at you now. Look at where you came from. Look at you now. Right. So this is all going to be like this. It's going to be like self dot. Well, that's not going to be it. So this is going to be like self dot asset is going to equal asset. And then furthermore, if it's anchor point or something like that, it's going to be self I think that's super. Self dot super. No, it's going to be super. Super dot anchor point. And then that's going to equal anchor point. Yeah. So, how do set a property of a superclass from a subclass? Come on, Jeff, put your back into it. Come on, Jeff, you can do it. Come on now, put your back into it. Tell us why, show us how. Look at where you came from, look at you now. Oh my god, ChatGPT, come on. Come on, dude. Come on. Saskia, where did you come from? Tell us why, show us how. Look at where you came from, look at you now. So if you're curious about all the quotes that I had, I was quoting Silicon Valley when I was talking about tabs and saying Richard. It's a part in Silicon Valley where the love interest of the main character presses the spacebar multiple times to taunt the main character about how she uses spaces in her code versus tab. And then the second thing I was quoting was a song by Bo Burnham about Jeff Bezos. And the third thing is I was just saying Saskia because that's a character from Magic the Gathering, and I have a deck focused or built around her. so you understand the references. Now you understand me. When a man loves a woman. Okay. Okay. So in order to set or modify a property of a superclass from within a subclass, you typically access the property directly or override it if it's defined as a variable in the superclass. Here's how you can do it. Direct access. If the property is accessible, e.g. it's not private and has the appropriate access level, you can set it directly from within the from the subclass. God. Superclass, variable property. We have the subclass. Setting the property. Perfect. Awesome. Overriding a property. If the superclass property is defined with the override keyword, you can provide a new implementation in the subclass. You need to ensure that the superclass property is defined as var and mark with the override within the subclass. Okay. So we'll just do it directly. So we can say, what about the super keyword? That's my question. What about the super keyword? Super keyword. What does that do? What does that do, mon chéri? Mon chéri, what does the super keyword do, mon chéri? Does it make caviar appear out of thin air? Now I'm becoming Mexican. So funny. Now I'm becoming Mexican way. It's time for the program. I'm doing push-ups, running around the block, getting tattoos, wearing my shorts all the way halfway down my jeans, below my knees. That's how you do it. Lean back. Lean back. This, okay, here's what ChatGPT is saying. So ChatGPT says the super keyword in Swift is used to refer to the superclass of the current class. It allows you to access and call methods, properties, and initializers that are defined in the superclass. Here's a detailed explanation of its use and how it works in different contexts. Calling superclass methods. You can use superclass to call methods that are defined in the superclass. This is useful when you want to extend or modify the behavior of a superclass rather than completely replace it. Okay? So what's the difference between direct access and the super or the override? Okay, so if it's overridden, you can use super to access the property of the superclass. You could initialize the superclass values. Okay, so I think we'll do direct access. We will just do this. So that's how it would work. You guys, I am super beat. I have to go to the bathroom, and I cannot possibly code anymore because... Actually, maybe I'll code some more, but I have to go to the bathroom. So this is going to seem like half a second to you, but it's going to be spliced on to the end of the video. I'm going to be gone for like 20 minutes. Ugh. Too much caffeine. I burped, gagged. Yeah. Excuse me. So I'll be back in 20 minutes. It's going to seem like a half a second to you. Peace out.